When you will come for your qualitative one analysis lab, you will be assigned one particular sample. All of these samples that you will be handed out for all the students, each one of you is responsible for your own sample, and you don't have to worry about other samples that I have shown on this Brightspace page. From the list of all the possible candidates, you will have to choose only one compound. That compound, its name, and so on. As soon as you get your sample, write the sample code and the appearance of that material in your notebook. You will then start to heat up your liquid, which is about 4 ml, in the sand bath. Always remember to keep a tile between the sand bath and the collecting vial. For this particular experiment today, you will only need one vial. Another point that you need to remember is to place your thermometer at the lower part of your side arm. If you do not do this, you will collect wrong temperature numbers. When you will start, there is a big possibility that you will get very low numbers. So for example, the first drop that you get may be at 55.3. But as you will increase the temperature, you will see a different number appearing. You need to get 10 consistent readings before you stop recording your numbers on the distillation table. From this distillation table, we will get our steady temperature of the boiling point range. So for example, in this particular example that I am showing you, what is my steady boiling point range? I see that I have these 10 consistent readings, which is the lowest number among all. 98.6 is the lowest number. What is the highest number that I see here? And I see 99.2. So this has become my steady boiling point, and this is what I'm going to record on my notebook as well as on my data sheet. When I have to figure out what is the possible candidates that I could have had, I will do a plus minus of 15 degrees Celsius. I will subtract from the lower steady boiling point number 15, and I will add a 15 to my higher value. What is the new boiling point range that I have obtained? It has become 83.6 to 114.1. Now this is a piece of information that I also want you to write in your notebook. How is this going to help us? This is the first piece of information that is going to help us eliminate or shortlist our compounds. We will eliminate all the rest and we will shortlist our compound. So let's look at this 83.6 to 114.1. 83.6 to 114.1. So among all of this table, I will see where is the temperature with 83 and 114. I'm not even going to look at the rest of the compounds now. I will only look at compounds 13 through 21. So this is my first shortlisting method. The second thing that you must look at is your IR, or the infrared spectra. Now always remember that IR can only determine the functional group of the compound. It will help you eliminate even further, and IR never lies. So if you have forgotten your infrared ranges and peak types, I would strongly suggest that you look at your IR packet and know for your course what ranges do you need to know, what peak types, and what shapes do you need to know. Once you have figured from your IR spectra, and let's say that this is my IR spectra, I will highlight all the 5 regions first. I will then locate what peak types are present in my IR spectra, and then I will list them in my notebook as well as in my data sheet. So this is the second thing that you must do for your solving the structure of your sample. Once you have figured out all the peaks, if they're absent, please state absent. If they are present, just record which peak type is present, sp3 or sp2ch or things like that. So from your IR, you will be able to figure out what kind of a functional group do you have. So for example, we are focusing only from 83 to 114. Let's say that my IR corresponds to an alcohol. It has a CO peak, it has a OH peak, and of course it has the sp3CH and I have figured out that my functional group is an alcohol. So looking at that, I will keep this, I will keep this, I will eliminate this. I will eliminate this, 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 and hence out of all the possible structures which I had shortlisted based on my boiling points, I am only going to keep these 2. The last factor to consider when you're figuring out your structure from given conditions is the refractive index, or RI. Always remember to read up to 4 decimal places when you're recording the RI value from the scale. Once you have figured your RI from your machine, always remember to take the RI of your water also. You need to do that in order to get the machine offset. This machine offset will decide how you will get your corrected RI value. So you have to obtain from the machine the RI of water, and for your sample, you will be given the literature value of RI of water. You will take the difference of these two. You will obtain your offset. If your machine is reading higher than the actual literature value, you will have to subtract your offset. If your machine is reading lower than the actual literature value, then you will have to add this offset. So this is something that you will have to decide at this point. When you will do this mathematical operation between the observed RI of the sample and the offset, you will get what is known as the corrected RI value of your sample. This is also discussed earlier when we had looked at GCRI and fractional distillation. For your RI, you also need to give a deviation of plus minus 0.050. So just like we did a plus minus 15 for your boiling points, you will do a similar plus minus for your corrected RI value. So if you look back at the data sheet discussion that I have, you will minus 0.0005 from this value and you will add 0.0050 to this value. You will get a new range. Let's say hypothetically, I get my range as 1.3881. 1.3881. And then I do plus and I will do a minus of 0.0050. This will give me 1.3831. 8 minus 3. And so I will also have to add 0.0050 to get 1.3931. So this is the range that we have to focus on. So if you remember, we had earlier focused from 83 to 114, and then we had eliminated all the non-IR matching compounds, and now I'm only focusing on these two. But looking at these numbers of the RI, which one do you think will be my product or my sample? Clearly, 2-methyl-2-propanol has a closer RI value than the 2-propanol. And based on this, I will eliminate all my other samples and I will say my unknown is this particular compound. And this is what I'm going to write on my data sheet as well. For my notebook, I just need to write the name of the compound and the corrected RI value of that particular compound, the range that you got.